Okay, well, thank you very much. This is our spring convective weather flight planning webinar. We have a group of folks who have collaborated to provide this information to you this evening. I'm Declan Cannon. I'll be hosting this webinar. I'll be joined by several of my colleagues and folks from regional offices within the Weather Service. And this is part of a national initiative, Ambassador Weather Ready Nation, a national initiative to bring safety and awareness to weather data customers across the country. And within that national initiative, we have the the Weather Ready Nation Flyers, a local group here comprised of individuals from the Aviation Weather Center in Kansas City. In Olathe, we have the Kansas City Center Weather Service Unit, and also the WFO, or the Weather Forecast Office, in Pleasant Hill in Missouri. I have quite a bit of material to go through tonight, and in that vein, we're kind of move along, maybe sometimes at a rather brisk pace, but there are opportunities for you to ask questions within the graphical user interface. If we are not able to get to those questions later on during a answer period, we will certainly be glad for you to reach out to us, contact us via email, which we'll show you in the contact info at the end, and you'll be able to submit your questions, and eventually we will be able to answer those questions. So again, this is all part of the initiative that we'll be taking you through this evening. And again, lots of information with this particular webinar. Okay, so without further ado, let's go ahead and talk a little bit about those folks involved. From the Central Weather Service Unit, we have Chelsea Kenyon, Brad T-Meyer from the Weather Forecast Office in Pleasant Hill, many individuals from the Aviation Weather Center, as you can see listed here, and we'll have brief bios for the individuals as we get through the program. Now, basically, we're going to go through 4 sections. We'll have initially a thunderstorm overview, some NWS convective products that you probably are somewhat familiar with. We'll do an example of what we would call a convective weather flight planning scenario. We'll briefly take you through a look at the capabilities of the Aviation Weather Center's graphical forecast tool. Also touch briefly with Stephanie Avey on the Aviation Weather Testbed, an opportunity for the pilot community to collaborate with other members of the aviation community. And then finally, you don't want to miss the National Transportation Safety Board presentation. Paul Suffren will be with us, and we'll take a look at a thunderstorm case study. So a very action-packed evening as well. And we're going to start out with Joey from the Aviation Weather Center here in Kansas City. And Joey will be talking about thunderstorm overview.
All right, well, thank you, Declan. And as he said, I'm one of the many AWC forecasters. Before that, I was a Weather Forecast Office forecaster in Pleasant Hill, Missouri, serving the Kansas City area. Before that, I was about 1.5 years. My first job was in the private sector as an aviation meteorologist. And going back a little bit further, I was in the Air Force as an in-flight refueler. So what I'm going to be doing is, for many of you, this is going to be a review. Maybe you'll learn a few things, but I wanted to touch base and kind of set the stage for what we're going to be talking about with convection. What are thunderstorms? How do they form? What are the hazards associated with thunderstorms? And in particular, what are the aviation hazards associated with those thunderstorms? So thunderstorms can form over any part of the U.S. At any given time of the year, but there are some hotspots in a typical season. Typically, our convective season runs from April to June as far as the most severe instances, but again, it can happen any time of year. You'll see here, this is an image from the SBC based on research from 82 to 2011, kind of highlighting where these hotspots are for severe convection. We're well familiar with Tornado Alley, but it's interesting. Over the last few years, we've seen an extension of that into the east along the Gulf Coast there, and Alabama's had their fair share of significant weather even over the last month. But it kind of gives you an idea if you're flying in these areas, it's something you should pay particular attention to on any given day. Just today we had some convection roll through the Kansas City area. Slide, please. So thunderstorms do need a few ingredients to form. They don't just happen instantaneously. They need a few things to get going. First of all, they need moisture. For this area in the Kansas City area, most of that comes from the Gulf. Elsewhere, it comes from the Eastern Pacific, the Atlantic, but we need some kind of moisture source. And that's why we look at dew point temperatures in the spring and summertime. They kind of give us an indication of where that what that moisture is doing in terms of trends, all based on wind direction and air masses coming into the area. They also need something to lift that moisture vertically, some kind of lifting mechanism like a cold front. That's a big one, an outflow boundary, any kind of triggering mechanism to push that moisture vertically. We need energy to maintain that vertical motion. We describe that as instability. And then for severe convection, we need wind shear, something to make that convection well organized and sustain it for a long period of time. Slide, please. So as thunderstorms form, they'll generally fall into one of three categories. It's important to note that storms don't always fit into these categories perfectly, and they can change from one category to another in a given time period. This all depends on atmospheric conditions throughout the life cycle of a thunderstorm or a group of storms, but generally speaking, they assume the form of a single cell thunderstorm, multi-cell thunderstorm, or a supercell. And there's a few other caveats, but this is very generalized, your very generalized type of thunderstorm activity. Supercells do produce the most significant activity when you see those. Slide, please. So we've all seen isolated, towering cumulus clouds form and grow on a hot summer day. If the conditions are right, these may form a single cell thunderstorm. They're typically very short-lived and produce the least amount of hazards in comparison to other storm types. But basically, these are very simple. The storm forms within a single updraft. They reach a mature stage shortly thereafter, and then they collapse within a 10 to 20-minute period. Heavy rain is likely with these storms, along with some small hail, gusty winds, and lightning. But these are the least severe in terms of thunderstorm activity. Next slide. And we'll see here a picture of your typical single cell thunderstorm, what you would see visually. You'll notice it's a nice day. Plenty of sunshine nearby. Obviously not for the residents underneath that storm, but it's an isolated instance. It has good vertical depth. These make for good time-lapse videos if you're into that, but they're very short-lived, very, very small, very isolated. If we go to the next slide, we'll see a radar image of what this looks like. This was, I believe it was yesterday over Louisiana. There was some isolated convection down there. I turned the lightning data off so you can see the radar imagery because these are very small isolated cells. If you see this starting to happen on radar, it may be an indication that additional convection is coming shortly thereafter. This is what you'll typically see to start off with, very isolated cells on radar. Next slide. So ramping it up a bit, we'll move on to the multi-cell cluster. These are thunderstorms in which contain multiple updrafts and downdrafts that occur at different intervals and are longer lasting compared to single cell storms. They form as the downdraft of one storm provides a lifting mechanism for a new updraft to form. This continues until the surrounding environment no longer supports the development of new updrafts, and these can last for hours. The associated hazards ramp up a bit with heavy rain and flash flooding possible, given that these storms sometimes move very slowly. So you can get training activity, as we call it, and a long period of rain in a short spatial area. We also see an increased possibility of downburst with this activity and large hail production. Slide, please. It's kind of hard to tell from the picture here, but we see different updrafts at different levels of maturity in the cycle of a storm. You can see the storm well in the background. It has a nice anvil to it. It's it's probably on its dissipating cycle right now, but the storms in the foreground are new convection. You'll notice the crunchy appearance of those new updrafts. And if we go to the next slide, we'll see an example from yesterday. This was over western Kansas. There was a multi-cell cluster forming. The storm over in Russell, right in the center of the page, that was a dissipating or a collapsing storm right there, but you had new convection growing to the north and south of that with the most mature storm in this particular timestamp. They're in Larned, Kansas. Next slide. Let's see. The other form of a multi-cell besides the cluster is that of a squall line. These are made up of a group of storms acting as a unit anchored on a boundary. They typically form ahead of a cold front or a dry line. Updrafts form at the leading edge of the line, and these storms may last for multiple hours and extend spatially for hundreds of miles. Tornadoes are possible within the line of storms, but the main hazards with these storms are primarily strong straight line winds and large hail production. And next slide. So we'll see an example of this on radar. It's very, very well organized. You can see a Boeing segment there in the center of the page. That's if these continue to mature, you can have very strong winds behind that Boeing segment. You basically have descending air behind that line of storms pushing out, and you can also have some tornado production in that area as well. But yeah, the main hazard with these are strong straight line winds, and unfortunately they cover a very long spatial area in a given amount of time period. They move relatively quickly given the air surge behind these storms, but they can be very damaging in terms of severe weather potential. Next slide. And the final storm we'll look at is that of the supercell. A supercell contains only one updraft, but it is one that rotates, giving supercells their corkscrew-like appearance. These form in unstable environments where significant deep layer wind shear is present. They're responsible for the most significant tornadoes and also produce large hail and strong winds. They're pretty neat anatomically. They have all kinds of things going for them. They contain a rain-free cloud base with the updraft there, a large area of precipitation surrounding the updraft, and a possible wall cloud. When precipitation is present around that updraft region, a hook may appear on radar imagery. We'll see that here in a little bit. With the right conditions and interactions within the storm and surrounding environment, a tornado may form, extending downward from the wall cloud there. Next slide. And this is what these look like. They're very photogenic, also very dangerous. You can see the corkscrew-like appearance there with the updraft, and you'll see the downdraft there in the center of that. Yeah, again, very, very well organized storms that do a lot of potential damage. Next slide. And this is what those typically look like on radar. Those two southernmost storms are both supercells. The one there at the southernmost point likely producing a tornado. The one up north possibly doing the same shortly in the near future. But yeah, they have a kind of a hook-like appearance with that rotation around the updraft there. If precipitation is present, making it visible. Next slide. We'll now take a brief look at particular aviation hazards possible with any type of thunderstorm. We'll start out with hail. Hail is basically particles of ice that form in a thunderstorm as liquid water droplets freeze as they are lifted above the updraft. Above the freezing level within an updraft, and then they grow in size as they are cycled through the updraft multiple times. These may grow up to the size of a softball or larger with the upper levels of the severe thunderstorms. It's important to note that small hail will often melt on its way to the surface. So if you're at the surface, you may not be thinking that any particular storm is producing hail, but it's usually present. Important for aviation purposes, obviously above the freezing level, even though it likely melts on its way down if it's small hail. The big concern with large hailstones is the likelihood of significant damage to the aircraft. And the presence of hail is even possible during or in the proximity of a thunderstorm, as strong updrafts may eject hailstones many miles away from the apparent thunderstorm itself. Next slide. Another hazard with thunderstorm activity is within the downdraft of a collapsing thunderstorm, known as a microburst. This may quickly result in the loss of lift, which is particularly dangerous on approach. It happens very quickly and in a small, very confined area. Next slide. And very briefly, we'll look at thunderstorm icing. This is possible in any thunderstorm as liquid water becomes supercooled and freezes on impact with a particular aircraft. This is most favorable when outside air temperatures range between 0 degrees Celsius to 15 below. Next slide. And finally, cloud-to-cloud lightning is present in every thunderstorm. Aircraft lightning strikes account for more aircraft damage than we think. Each commercial aircraft on average being struck more than once during its time of service. The electrical charge from lightning may induce currents into the wires of equipment beneath the skin of the aircraft, and there are numerous reports of non-catastrophic damage to wingtips, propellers, and navigation lights. Slide, please. I think we've got a few text points here. And finally, the other primary hazard associated with convection is turbulence, which Ryan will be speaking on next.
Hey, good evening, everyone. My name is Ryan Solomon. I'm the Science and Operations Officer at the Aviation Weather Center. I've been doing that for about 2 years or a little more, and before that, I was the Techniques Development Meteorologist at the AWC since 2007, and then before that, doing various other software engineering roles related to meteorological software. So that's who I am. So I'm going to talk with you about convectively induced turbulence. You can go ahead, Declan. So first of all, let's just establish what convectively induced turbulence is. What we'd like to use for our definition is turbulence whose source can be traced to deep moist convection. And that can be both in cloud and out of cloud. And the reason we're going to talk a little bit about turbulence and convectively induced turbulence is probably one of the more underappreciated, overlooked aspects of thunderstorms. It's clear you can see cloud, you can see rain, you can see hail shafts, you can see a lot of stuff, and sometimes you can't see turbulence. There's areas of thunderstorms where turbulence is especially dangerous, and you wouldn't necessarily know it's there. The thunderstorm you see here in the middle, and I think this is the same graphic Joey just showed of a supercell, and you can see the updraft depicted with the red arrow. And updraft speeds in thunderstorms is fairly phenomenal. Just your general kind of single cell air mass thunderstorms can be 1,200, 2,500 feet per minute, on up to supercells, which can be 6,000 to 12,000 feet per minute. So these are definitely storms you wouldn't want to have anything to do with an aircraft. You want to avoid it a long ways. Now the FAA guideline on that says 20 miles from any thunderstorm that's identified as severe, or giving an intense radar echo. And they say this is especially true under the anvil of a large cumulonimbus. And we'll discuss a little bit about why that is. But I actually think I think some of the research shows that 20 miles is even a bit conservative, especially with something like here that you see on screen. I would stay as far away from that as you can possibly get. The winds can be, the wind shear, the turbulence downstream from these, and even upstream a ways, can be quite intense. Next slide, please. Just a few stats, and I hope I'm not gonna step on Paul's talk later. These are from NTSB. They might be a little dated. The one on the left is more heavy aircraft. I'm not sure how many of you would have an interest in that, but it is good for demonstrating how dangerous it is. So turbulence, while fatal accidents are fairly rare, they do happen, even with heavies, as you see here listed on the left. Now, for general and smaller aircraft, it's perhaps a little more common, especially when you talk about, and if you hit one more slide, Declan, if you look at flights into thunderstorm. Now, I don't know that this chart, this doesn't necessarily say that those flights into thunderstorms that you see there, 30 39 fatalities were necessarily turbulence related, but I would bet it certainly played a role. So it's an area you definitely need to be aware of as a pilot, and make sure you avoid thunderstorms. Okay, next slide. So just real quick on intensity, I highlighted the areas I thought were the most poignant about, kind of illustrating the different levels. So, light, you could say a slight strain against your seatbelt, moderate, a definite strain against seatbelt, and if you don't have something secured in your cockpit or the cabin, it could go flying. Severe is definitely, you're going to know it against your seatbelt, and more importantly, the aircraft may be momentarily out of control. I think that's where they really start, where that moderate to severe delineation really comes in, is where if you lose control of the aircraft, even temporarily, it's probably at least severe. And then extreme, yeah, you don't, now we're talking structural damage, and unfortunately could potentially accident. Okay, next slide. So let's look at a little bit of some of the same graphics that Joey showed, but let's look a little bit about thunderstorm structure and where in those thunderstorms you would expect to see the highest amount of turbulence. And so on the left graphic there, and we've used the red arrows to try to highlight it. You've got the updraft, as Joey explained, and that's your airflow into your storm up, and that's you're forming your cloud. So you definitely don't want to be in that updraft. You definitely don't want to be right under it where it's going into the cloud. You don't want to be above it. Even though that cloud may end up there, there's still rising air above that. That's just where you see condensation. So and the cloud forming. So you definitely don't try to top that, or at least very close. On the right side, this is more of a mature or decaying thunderstorm. At this point, you've got a downdraft. So this is rain-cooled air falling out of the cloud, and as that rushes to the ground, obviously it hits the ground and it has to go somewhere. So it goes out. We call that a gust front, as it's depicted in the diagram. And as you see, with the aircraft there, this is definitely not a place you want to fly into, especially, in this case, they were trying to land, it looks like, and that could cause contact with the ground. So not a good place to be. Okay, Declan, next slide. Now this is, I'm not sure if Joey showed this one, but this is I apologize for how busy it is, but this is a depiction of the supercell. So there's a lot goes on in a supercell that makes it extremely dangerous. I mean, this is basically a turbulence making monster everywhere you look. So you've got the tilted updraft and your red arrow, and I don't have a pointer or a way to tell, but so that's where the mesocyclone is. Your tornado would be extending down, if there was one, to the ground from there. You've got your rain-cooled air and your downdraft going out to the front of the storm, and that's going to have your gust front and the shelf cloud. I think I have a picture of the shelf cloud coming up. If you look at the anvil, now not most of you, and I put this height indicators on the right side just to give you a rough idea of the kind of scale that we're talking about. And if you're GA and an unpressurized, plane, you're probably not having to worry about flying up in the anvil level. But for the purposes of this discussion, the anvils stretch out a long ways, usually, if on a mature storm. And sometimes you'll see mammatus, and we're going to have a picture of mammatus here later, but you might see mammatus on the underside of that anvil, which is a good sign of turbulence. And sometimes you'll see virga underneath that as well, and that is indicative of evaporative cooling, or of air that's rain-cooled air that's evaporating, that can speed its descent to the ground. So you don't want to be in any of those areas. So really, if you look at this whole thing, I would say steer as far away from this sort of storm as you can possibly get, because there's going to be turbulence hazards well away from the areas where you just see cloud or rain, or so yeah, definitely not something you want to mess with. Okay, next slide. So let's talk about a couple of the threat indicators. This is an infrared satellite image that's just in grayscale, no coloring for brightness temperature, but the reason that was created that way is so that we could overlay radar on it. So I wanted you to see that cloud shield is rather large. And now the core area storm, say down in, say, like the St. Cloud area, fairly small. This is probably even possible. This is maybe it's this storm that's been going on a while. So you might look at that and think, I could fly from Duluth to Grand Forks and not really encounter, there's no echoes, no thunderstorms on radar showing up between there. But sometimes there's turbulence, convectively induced turbulence in these areas that makes it kind of hazardous. So what we're showing you there is what we refer to as transverse banding. You can see these sort of lines in the cloud structure, striations, and that's indicative of waves and indicative of turbulence. So if you aren't paying attention, and next slide please, to some of the products that we output, you might, so this is convective sigma. This is, I think, the convective sigma that was put out for this event. And, you might think at first glance, if you're looking at reflectivity or radar, you might think, why in the world did they draw that so big? And I don't want to guess what the forecaster was thinking, but if it were me, I would have drawn it up north just like they did to capture that area of convectively induced turbulence. We can't always see it on our data that we look at, but in this case, you could see that satellite signature fairly clearly, and they might have also gotten some reports that triggered that. So it's just important to pay attention and not necessarily just pay attention to what the meteorologist is saying in the products, and be careful when you're interpreting your radar, because there can be some hazards outside that you're just not aware of. Okay, next slide, please. So as I mentioned earlier, I had a picture of a shelf cloud. So this is kind of your leading edge of the gust front. That rain-cooled air hits the ground and rushes out and tends to curl back up and kind of create this this interesting looking cloud. And it's got a horizontal rotation to it, and it's highly turbulent. You definitely would want to stay well away from that if you see that. And on the right, so we're looking at a supercell that's got a wall cloud hanging down from it. This is just indicative of a supercell. As we already talked about, you would not want to get anywhere near that. And I would argue that at this picture, of course, this is not from an airplane, thank goodness, but if you could see that level of detail structure, and this meso is probably, a couple thousand feet from the ground, you wouldn't want to be that close even in an aircraft. So I would suggest going the other direction. Okay, next slide, please. Mammatus, as we discussed earlier, this is indicative of turbulence, and usually a lot of times most of the time you'll see this under the anvil of a strong severe thunderstorm. Again, it's sinking air. Now, one thing to be really careful about with Mammatus in this environment, just because you're not flying, these might be up at, I don't know, 30,000 feet or something, and just because you're not flying up that high, that sinking air is still most likely going to be lower than that. You're just getting the condensation of the cloud at that level, so that makes it visible, but that sinking air is there possibly all the way to the ground. So it's a dangerous situation, not necessarily super turbulent, but this picture, you can tell it is. Not always. Sometimes they're a lot less defined and maybe not as turbulent, but it's certainly an area, especially if you're in a small craft, to stay away from. Okay, next slide, please. Virga, as mentioned earlier as well, this is evaporative. This is rain falling on your cloud and then evaporating before it hits the ground. Well, that evaporative cooling causes that air to rush down to the ground even faster. So you see, you'll hear about downbursts, microbursts, things like that, and those are just differences of scale, whether or not it's a large area or small area. But that's a very dangerous situation, as we saw earlier with the graphic and the plane. Trying to land in that, that can force you right to the ground in a hurry. You're already heading to the ground. You're already slowed down your airspeed, and then you get hit with that, and it can be bad quickly. Okay, next slide, please. So bottom line is steer clear of all thunderstorms. And next slide, please. How do you do that? So on my last couple of slides, I just want to give you a snapshot of a couple of tools that I'm familiar with working at the Aviation Weather Center, as well as some of our partners like the Storm Prediction Center and our CWSUs. So on the left, you've got hours, and this is just kind of roughly how many hours before your flight. This gives you some idea. So if you're looking in the 12 to 30, 12, 24, 30 hours before your flight, we have a product called the Extended Traffic Flow Management Convective Forecast. That's a mouthful, and I'm going to give you the URLs for these products in subsequent slides. So that's one tool you can use. SPC, of course, you're probably already familiar with their convective outlooks. So your day one convective outlook is a good resource. Keep in mind that that's mainly tailored to severe weather, severe thunderstorms. So it doesn't take a severe thunderstorm to significantly impact a flight, especially with a small aircraft. AWC TCF, so that's our the eTCF is our automated long-term, longer term product, and the TCF is our human-produced collaborated product. So that's good on your 2, 4, 6, 8 hour forecast timeframes. SPC thunderstorm, severe thunderstorm, and tornado watch, of course, we're all familiar with those. Our convective SIGMETs at AWC that we produce, we looked at one earlier, so that's good. 0, 1 hour. They will say they're valid for 2 hours. It's just not, if you don't have anything else, I would go with that. But we do update those every hour. Our CWSUs, they put out. We work fairly closely with them on our convective products, so convective SIGMET, and then the center weather advisories that the CWSUs issue. Same thing. They will be covering thunderstorm hazards. Sometimes we have same areas covered. Sometimes we work in partnership to try to cover everything in the airspace. I have GTG on there. GTG is a graphical turbulence guidance product, and it's right now, and if you look, there's a footnote that says CIT is currently being added to future versions. That's because right now it's not. It's mostly a clear air turb and mountain wave turb product. But in future versions, they are building in the ability to do to identify convective-induced turb, and it's going to be more of a rapidly updating product. So keep watch out for that product. I don't have I don't have good intel on the timing on that. It's probably still a couple years off. So, but it should be a really good, useful product for you. And then of course your 0 hour, you're on. I'm getting ready. I'm about ready to take off here. That product, or you're in the air, is your radar. And again, just be careful with radar. Sometimes it's not, it doesn't give you always a complete picture of the hazards out there, especially when you're talking about turbulence. And I think that's all I have. I just want to maybe real quickly, just the next couple of slides. I'm sure we're going to make all of these slides available to you, so don't feel like you got jot these down, but I'm giving you the URLs for the products that I just showed you, and then one more. Yep, there's another page. Okay, one more, Declan. I think this is my last slide. And then I end this with some references and resources for you. These are some turbulence, convective-induced turbulence, and also some good information general information about thunderstorms. So I hope this is useful for you. And of course, always feel free to ask questions, send me email, and I'd be happy to help however I can. Thank you very much.
All right, good evening, everyone. I'm Brad T. Meyer. I'm with the Weather Forecast Office in Pleasant Hill, Missouri. Over about the last 15 years, I've worked for the National Weather Service, starting and mainly just in the Midwest, but like I said, now focusing mainly on the Kansas City area. So tonight I'm fortunate enough to be able to talk to you a little bit about some of the products and services that we provide that will help you plan for your flights. So we'll go ahead and get started if you want to go to the next slide, Declan. Okay, so I want to talk a little bit about a surface prog chart, and the URL there is at the top of the screen if you want to access this information. Basically, what this does is it's a really nice overview of any potential weather hazards that you might face in a planular format. So you can see where your fronts are, you can see where the precipitation is expected associated with that, and you can also forward that in time. If you look in the upper right-hand corner there, you can see a time bar. And it's got arrows both forward and backward. You can move these maps in time, and that way you can see what the weather is expected to do in your area of interest as you're planning for your flight. Let's go to the next slide. One of the things that both Ryan and we talked a little bit earlier about is the storm prediction forecasts. So generally, the storm prediction forecasts are on a category scale and go anywhere from a general thunder outlook up all the way up to a high outlook. The high outlooks are typically relatively rare, only issued a few times throughout the year. In this particular case, on today's instance, for example, it was an enhanced risk, so a level 3 out of 5 scale. And they do this on a daily basis. So they'll go out through day 1 and then all the way out to 8 days. I will say though, once you get closer in time frame, we can be much more accurate with the information, and we do break it down a little bit more in detail. So if we want to go to the next slide, here's an example of what some of the probabilities would look like on both day 1 and day 2. And those probabilities are associated with different types of how widespread the expectation is for severe weather. And that's all based on what Joey talked about earlier with in terms of how much wind shear you have in the atmosphere, along with those other ingredients of moisture, lift, and instability. So basically what we're looking at here is you can have, if there's isolated severe storms possible, they might throw out a marginal risk, and then all the way up to a high risk, which means that there's widespread severe storms expected, and certainly going to be any impacts associated with any convection at all. Let's go ahead and go to the next slide. And so they do have probabilities associated with those risks. So if you think about it, the way these probabilities break down is basically you're looking at within a 25-mile radius of any given point and the associated probability thereof. So for example, if we look at the 2% probability for tornadoes, that's a marginal risk, but a 2% of having a tornado within 25 miles of, let's say, for your house, for example, is a pretty high probability than what it would be on a typical day. So that's why it's associated with a marginal risk. And you can see that those go all the way up. And then once you get up to a 30% or higher, that's associated with a high risk. Like I mentioned, those high risks are relatively rare. You've noticed that high risks for wind and hail are relatively rare, but you can get an instance, just like we had with the derecho up in Iowa that moved across the Great Lakes region, that sort of thing. When you get widespread, significant impacts of wind, you can get up into that moderate and high risk category for those wind impacts. Similar for hail, you max out generally at a moderate, but obviously, especially when you're flying, that hail is going to be larger up where you're flying than what's measured and falls down to the surface. So it's just best to avoid all convection together. Let's go ahead and go to the next slide. So one of the things that we do at the Weather Forecast Offices, we have 122 weather forecast offices around the country, is we write aviation weather discussions. And these are updated at least 4 times a day, sometimes more than that, depending on how conditions are and what time allows for. But you can get this information on aviationweather.gov/forecast discussion, or you can get it on the local Weather Forecast Office page. So if you go to weather.gov, click on the map there for the area of interest that you're looking at in the country, and that will take you to the local forecast page. If you go under the discussion drop-down menu up at the top, that will drop to a pull-down, and you can just pull down forecast discussion from there and access the information that way as well. But what this was really great for is it really highlights a lot of information that's kind of going on in the meteorologist's head that's writing both the task and the forecast itself. So you can get a lot of information about the weather picture and any potential hazards. So in terms of flight planning, it's a really great tool to get a sense of what's going on, especially when we write TAFs or terminal aerodrome forecasts. A lot of times we can't include certain things in the TAF for various reasons, or we're just not thinking that there's a greater likelihood to include it at that point. But we can still highlight that information in a particular in an aviation discussion. So, for example, we're expecting fog or convection. Unless we're expecting it to impact that airport specifically, we're not going to include it in the TAF, but we would discuss it in the forecast discussion. So this is really going to be a location where you can get a lot of heads up on the various different weather conditions that are expected around the area and any potential hazards. Let's go ahead and talk about TAFs now. If we go to the next slide. So TAFs are basically terminal air and drone forecasts. We issue them at least 4 times a day, and then they're amended as necessary. They are only valid for a 5-mile radius of a particular airport. So like I mentioned, if we do have that fog or convection or any inclement hazard that's in the area, but it's not impacting that airport directly, it's most likely not going to be included in the TAF unless we're expecting it to impact that area. I have here on the right an example of my first storm chase back when I was in college. You can see this was up at the Waterloo Airport in East Central Iowa. You can see a tornado in the background, that sort of thing. Unless we're expecting that tornado to form within 5 miles of the airport, it's never going to be included in the TAF. And you can get that additional information in that forecast discussion. So that's why it's good to use these products in tandem with each other, so you can really get a good sense of the weather picture. You know, Part 91 suggests that you really need to be aware of all the weather hazards that are out there, and so it's really good to use all these different products so that you have a good sense of what to expect when you're planning, and then you actually go on for your flight. So let's jump back to TAFs now. TAFs are mainly comprised of a couple different groups. A from group, which is going to be the prevailing group. Oh, can we go back to the previous slide there? From group, which is basically going to be the prevailing conditions throughout the period. A tempo group, which is going to be temporary conditions. We try to keep those as short as possible, so we'll use those for reductions in visibility or convection. And then a Prop 30 group, which is going to be out past 9 hours in the TAF, but it's going to kind of give you a heads up of some potential hazard that may be there. And then one final thing that I didn't have room on my slide to include is low-level wind shear. So that non-convective low-level wind shear we include in the TAF as well. That's going to give you obviously a loss or an increase of lift depending on how that low-level wind shear is oriented compared to whether you're taking off into it or landing. So we include that with direction and speed in instances when we're expecting basically 35 knots or more in the lowest 2,000 feet. With that, I'm going to turn it over to my counterpart, Chelsea, and she's going to talk a little bit about what the Central Weather Service Unit does.
All right, thanks, Brad. Hi, everybody. I'm Chelsea from the Center Weather Service Unit here in Kansas City. I've been at the center for about 11 years, and I was a flight service briefer before that in Fort Worth. So I've been around aviation weather for about 15 years, give or take, and it is my passion. So I love talking to pilots, and now I get to talk to controllers. And so I've been kind of on all the different sides of aviation weather. So I do want to pick up, we've kind of talked broadly about all of these different thunderstorm hazards. Now I want to focus in more on your red flag type products. So we're going to pick it back up with the TAF. Pilots love the TAF, right? It's high certainty stuff. It's focused on the airport, and you can get a lot of information. There's a lot of different ways that you can look at TAF information. So if you look at the Aviation Weather Center TAF page, you can see them with the little flags there. Sometimes the flight categories are highlighted. So there's a lot of different ways that you can look at that information. In the center, when we're briefing controllers, we actually use more of a dashboard forecast, hour by hour, color-coded to highlight the hazards so that they can plan for wind shifts that might change runway configurations, low ceilings, thunderstorms, gusty winds, any of those kinds of things. But as Brad mentioned, the TAF is really just for that 5-mile area around the airport, and the vicinity only goes out to 10 miles. So unless something is very high confidence that it's going to happen within that range, you're not going to find it in the TAF. So it needs to be at least 50% probability or greater to be included. But that's where that forecast discussion comes in handy, because sometimes if you expect it to be there and then it's not there, you can read that and kind of see behind the curtain and figure out what the forecaster was thinking and why they didn't include it. It's probably a confidence issue. Maybe the probability is not high enough, but you could expect changes throughout the day, especially if there was low confidence. So that's something that you can watch for in the TAFs. Next slide, please. So another tool that you're probably becoming familiar with, it's fairly new. This replaced the area forecast. It's now the graphical forecast product, and it is on the aviation weather page. Very popular with the general aviation pilots. this should be your one-stop shop when you want to look at what's going on out there. So if you're planning a cross-country flight and you want to know who is predicting thunderstorms in their area, you can look at this thunderstorm coverage forecast. So this comes out of a collaborated forecast product that all of the offices talk to each other. They make sure that one neighbor is not showing higher percentages than the other neighbor. They want to make sure that everything is consistent. And so you can look at this and you can step through in time to see how the forecast is going to change. So maybe you're trying to decide, or am I going to take off in the morning? Am I going to wait and see what things happen in the afternoon? You can look at this and it will show you how those thunderstorms are expected to develop throughout the day and how the situation is expected to evolve, so that you can make those choices as to what your route of flight is going to be, what time of day you want to go, or even to go or not go. So this is a great one-stop shop, and you can look at that within a couple of hours of your flight and know what's expected at those sites. Next slide, please. So once you're on the way or even getting ready to take off, we've got the satellite and the radar, right? So those are things that we've had for a long time. You're probably pretty familiar with looking at them. One thing that you can do, we have some new satellites that have just come out in the last few years, and they're providing a lot of enhanced imagery. We have very high resolution images, so now you can see individual cloud elements. You can see a lot of different layers, and sometimes looking at something in color can show you different layers of the clouds. So you can tell what's high cloud blowing over and what's the cumulus cloud underneath. So those are really good ways to kind of get a sense of what you're about to fly into before you take off. I would highly recommend taking a look at some satellite imagery. Next slide, please. But radar is really where it's at. We're all familiar with radar. We love radar. So there's a lot of different ways that you can depict it. You can look at it. A billion different sites. You probably got it in your cockpit or in your electronic flight bag. So making sure that you're looking at the radar, this is what's happening right now. Keep in mind that if you're using Garmin Weather or some other third party, make sure you know how long it takes the new scan to get into your system. Sometimes it could be a couple of minutes old. So make sure that you have the most up-to-date information when you're making those decisions. This page actually shows you the watches and the warnings as well. So anything that's actually out there now being warned by the National Weather Service, those aren't aviation specific, but it can tell you where the really bad storms are, and you definitely don't want to go there. So that can kind of give you a sense of where things are really bad and where things are going to be moving to, so that you can make those choices as well. A couple of different ways to look at radar. Let's go to the next slide. So I pulled this off of SkyVector, but if you're using Garmin or ForeFlight or any of your products, there's a couple of different ways that you're going to be visualizing the radar in the cockpit while you're flying. So on the left-hand side there, I've got the radar turned on, and then I also have convective segments that are plotted over top of that. And as you can see, these boxes might be hard to see, but the light blue boxes around that are hugging those thunderstorms pretty closely. And as Ryan mentioned, sometimes they can expand to larger areas to cover other hazards that may not be visible, like convectively induced turbulence. So that's something to keep in mind. On the right-hand side, I still have the same convective segments plotted, but this time I turned off the radar and I turned on the surface observations on the map there, and also the pilot reports. So there's lots of different ways that you can visualize and see kind of how things are in the atmosphere, what's going on right now. Those are really good ways to kind of visualize. Nice thing about SkyVector and some of the other ways of visualizing things is you can plot out your route of flight, and then if it goes right through a convective segment, you can just take that spot and drag it over somewhere else, and it will plot out a new route of flight for you. So it's really easy to do your flight planning that way, especially if you're close to takeoff time. But even once you're in flight, you can make those adjustments on the fly. And always talk to air traffic control if you have any questions about what they're seeing, because they do have the most up-to-date radar. So even if you have radar on board, that radar is part of the picture. It's not the whole picture. So it's important for you as a pilot to tell the controller what you're seeing, and the controller is required to tell you what they're seeing. And so together you can get the full picture, so you can know, can I make it through that gap, or is there something behind that next cell that I'm not seeing? So it's really important to talk to ATC if you are on the radio with them. Next slide, please. So as we've mentioned, the Center Weather Advisory is kind of a unique product. It is issued by the CWSUs all across the country, and it's a weather warning. And it's a warning specifically for aviation, just like a convective SIGMET. So each CWSU will issue that for their own airspace, and it has about the same time frame. It's good up to 2 hours, but for thunderstorms, we usually replace it at the top of the hour, or a convective SIGMET will pick up that area if something is just developing. Sometimes you'll see them for other things like turbulence or IFR, icing, any of those things. The important thing to keep in mind with all of these products, convective SIGMETs, center weather advisories, any kind of convective warning product is going to imply all thunderstorm hazards within that box. So even if there's no thunderstorm there, you could be looking at an area of showers producing severe turbulence. There's a lot of different ways that we want to warn you about convective hazards. So showery precipitation is still considered convective, and virga, as Ryan mentioned, is also a convective hazard. So just be aware of those things as you're making your flight plans. Next one, please. So this is an interesting image. This is kind of the NAS view, the wide view of what happens when you have a big area of weather right in the middle of the country. So keep this in mind if you're deviating around a line of thunderstorms. You can kind of see where all the flight tracks, all the pink lines are flight tracks. You can see where they all bunch up at the north end and the south end of that line of weather. That's where everybody is deviating to get around, because as you can see, not very many tracks are going through that weather. So be kind to your air traffic controller if you are deviating around those lines of weather, because the controller on either end of that line is not having a great day. They're very busy. If you're deviating around weather, you're very busy too. So it's important to just everybody keep your cool, listen to what's being said on the frequency, keep those frequency chats short and to the point. And if you can, try not to ask the same question that the 3 pilots ahead of you asked. Everybody listen to each other, and then that will really reduce the workload for everybody involved. But we call that the eye of the storm, because that's a really good day for somebody in the middle of the country and really bad day if you're on either end of those lines. So with that, Declan, I'll hand it back to you.
Okay, thank you very much, Chelsea. Also, Brad, Ryan, and Joey for the presentations. Kind of gives us a foundation, an enhanced awareness of a lot of the product line. And what we'd like to do now is to kind of take that knowledge base, look at a convective flight planning scenario, and we'll show you the flight path here in just a second. Before we do that, though, we just want to reiterate, this is just focusing solely on AWC and the National Weather Service convective related products during various stages of the flight. And also I want to point out that one of the things that we're really quite proud of is that we've had an opportunity to update the Pilot's Guide to Aviation Weather Services. You see the URL or the link there for the internet. Also, just recently, about 3 weeks ago, in fact, the FAA has updated the advisory circular, the AC 9192. And so that's an excellent source for you for pre-flight briefing, roughly about a 21-page document. You'll get a lot of valuable information in there. And of course, as always, remember that these product lines from the AWC and the NWS, it's not a substitute for legal pre-flight briefing. So you want to use 1-800-WEATHER-BRIEF or whatever your favorite flight planning service is to satisfy that quota for the standard briefing requirements listed in 91.103, which is the pre-flight action. Basically, the pilot needs to be aware before takeoff of all aspects of the flight, and certainly one of those is the weather. So here's what we're going to take a look at. We're going to go ahead and do this hypothetical flight from Gardner, Kansas, southwest along a straight line down to the Fort Worth area. And we're going to look at it from 2 perspectives, both Amanda and Amy from the Aviation Weather Center. Amanda will first look at a pre-flight scenario, some of the information involved in that. And then Amy will take over and look at some of the aspects involved when you're looking at it from an en route perspective. So we'll go ahead and do that now. And then following that, we'll kind of take a quick tour through the GFA on the AWC website, provided yours truly can drive a little better than I did there at the beginning. But again, we'll go ahead and start off with Amanda.
Good evening, everybody. Excuse me. Okay, so we'll just get right into it. So our prior to departure, we'll look at what's going on in the morning before we're going to take off. We're planning a later afternoon flight so we could get landed before dark. So checking out the radar and satellite, which Chelsea talked about, is, that's the main thing. We really need to look at that stuff and see what's going on. So you can see the flight path is on the screen there. So it looks like towards our destination, we're seeing MVFR and IFR conditions. So low clouds, reduced visibilities. You've got some storms in the area. Even from our departure airport, it looks like once we get just a little bit farther south of that, we run into the low clouds, and there's a very clear line of where it looks like that storm system is moving through. Next slide. So looking at the surface charts that Brad mentioned earlier, you can see that there is a very well-defined cold front that's going to be moving across our area. It looks like it is very close to our route, and that by the afternoon time, it should be well to the east, but we are left behind with a large area of rain predicted. Next slide. So our morning TAFs from our departure airport, it looks like they're going for some overcast low clouds, and then it starts to break up during the late morning hours. By the mid-afternoon, I would say, we scatter out, but we have some winds to deal with, and then we're SKC after that in the evening. And at our arrival airport, it looks like the clouds we've got low clouds, overcast. Throughout the forecast time and the flight time, the potential time that we're going to arrive there, we've got vicinity thunderstorms, CVs in the forecast, continued low clouds. Next slide. So going to look at the outlooks here, we've got our SBC outlook, which shows we do have a slight risk, and a marginal risk, it looks like, is what our arrival airport is going to be in. And then we've got some general thunderstorms across Oklahoma along our route. And then for the other outlook, we've got our convective sigmet outlook, which you can see there's a couple convective sigmets valid in Arkansas and Oklahoma and very northern Texas. But as far as outlooks go, it's still pretty much the same area that SPC has. So we are expecting thunderstorms to continue in that area with the potential for them to have convective sigmets issued. Next slide. So the GFA, this is the forecast for our ceiling and visibility, starting out at 19Z, and then we'll continue on from there hourly. So our flight path is on there in the pink color still. So you can see close to our arrival airport, we've got the blue, which is MVFR conditions, so your marginal visual flight rules. Continuing on to 20Z, still there, but it looks like it is moving eastward. Continuing on to 21, same thing. Looks like the trend is still continuing eastward. Next slide. So by 22, it looks like most of our route is pretty clear. 23, it looks like even more so. And then by 0Z, which, we could potentially be arriving around that time, it looks like the low clouds have moved to the east of our arrival airport. Next slide. So here again, these are taken from the GFA as well, which Chelsea talked about, and Lewis put a chat link in the chat for it. Excuse me. And this is our weather. It's called our precipitation and weather is the green image, and then our thunderstorms are your red image. And again, we'll go from 19 to 0Z. So I have them side by side. Our line still is in pink, and you can see again, our route is expected to have rain along it, some thunderstorms as we get closer to our arrival airport. But again, that's at 19Z. So we're probably going to be taking off from our departure airport at that point. By 20Z, we're continuing seeing the same thing. Next slide. By 21, we're starting to see the storms move off to the east again. We're still seeing some precipitation, some rain along the route. but most of the thunderstorms and the really high potential for thunderstorms is moved to the east. Next. And that trend continues for 22Z. It looks like the main area of thunderstorms is going to be off to our east, but slightly. We're still going to be seeing some precipitation and some rain, it looks like. Next slide. 23, even more so. Looks like it's clearing up a little bit more along our route. Next slide. And by 0Z, which is potentially our arrival time, it looks like most of the activity is to the east of our arrival airport, but we may still see some rain. Next. So one thing I like to look at is our impacts task board. You can see the web address right underneath that. And this is just going to have it out for you. And it's broken down by the hours. So you can see in the orange and red that for, let's see, it says 17, 18, and 19Z. You're going to have vicinity thunderstorms and some thunderstorms and light rain. But then after that, there's nothing in the TAFs. Next. So we've got a, here's the PIREPs, and this is for our late morning, early afternoon time frame along the route. So you can see there's actually a convective sigma on our destination airport, and there's some moderate turbulence PIREPs, and there's actually a severe as well in central Oklahoma along our route. Next. So we'll look at the convective sigmas now, and again, this is going to kind of see what the trend is looking like. So before at 16, when we saw the PIREP, you could see that the storms were over our arrival, our destination airport. And so then now at 18Z, 2 hours later, it looks like the convective sigmas have moved to the east. So that means, the main thunderstorms are off to the east. We're still seeing some rain showers along our route. It looks like the threats are severe. So we're seeing 60 knot gusts, hail to 2 inches in those. So 19Z C-SIGs continuing to move eastward. Next. By 20Z, it's well to the east. It looks like the showers are starting to wrap around a bit on the west side of our route, but the main thunderstorms have moved into Arkansas by this time. So I think, all right, now it's Amy for our flight.
Hey, thanks, Amanda. Hi, everyone. Good evening. I'm Amy McPherson, a senior meteorologist here at the Aviation Weather Center. Let's continue on right away with our case study. So we're taking off from Gardner, Kansas again. It's about 21Z. It looks like we'll be in the air about 3 hours and a landing time of around 0Z at Fort Worth Alliance Airport. Taking a look at the latest information around takeoff time, the latest TAF shows we have VFR conditions. The latest observation has VFR conditions. The latest observation there at the bottom of the slide says we have winds out of 340, 16 gusts 28 knots. So we're a little bit on the gusty side, but that's no problem for you. It looks like our takeoff location is good to go. Looking at for the next slide, looking at our arrival destination, the current conditions at Fort Worth Alliance. We have winds out of the northwest at 13 knots, but we have overcast skies at 2,400 feet, so we are MVFR. And you'll have to decide whether or not that's something that you are comfortable with landing in, or if you are strictly a VFR pilot. But looking at the TAF, you see that our expected arrival time at Fort Worth is 0Z, and it looks like by 0Z, the TAF they're forecasting overcast at 5,000, so that makes it VFR. And so as Amanda said, with everything trending off to the east or moving off to the east and northeast, we kind of expect those lower clouds to keep moving off and then those VFR conditions to come into the area. On the right side there, the visible satellite, the dots are the ceiling categories, ceiling and visibility categories. So the blues are MVFR, the reds are IFR, and the greens are VFR. And you can see our destination is right in the MVFR, but the VFR conditions are not far off to the west. Okay, next slide. Checking the latest PIREPs before we take off along our route. We see that we have thunderstorms off to the east and a moderate to severe pilot report at 8,000 feet, but that is still well off to the east of our flight route. And as Amanda, as we looked at, we're expecting everything to continue to move off to the east and northeast. Okay, so we're good to go for takeoff. Shortly after takeoff, you get an update with an amended TAF for your arrival site. Looks like they are expecting those MVFR ceilings to stay around longer than expected. And so we're not expecting VFR conditions until Tuesday at the Fort Worth Airport. You check the current conditions again, it still says overcast at 2,400 feet. So at this point, again, you need to decide whether or not you're comfortable with landing in that, or if you're strictly a VFR pilot, you have to start maybe thinking about different options for your flight plan. Okay, next slide. And you take a look at the latest graphical forecast for aviation cloud guidance for 0Z, because you're wondering, well, what does the GFA say about the clouds? It has scattered at 015 at DFW, which is just to the east of Fort Worth Alliance, but you can see those lower, those darker blue colors kind of showing those lower clouds lingering around your destination site as well. So that doesn't really give you a clear-cut answer of whether or not it's going to be MVFR or VFR when you arrive. Next slide. So you check the visible satellite and radar trends, of course. We're always wanting to check the latest trends for that. Again, those thunderstorms continue to build off to the east and the northeast. There's some light rain showers moving through the area, which looks like you're going to have to fly through on the way to Fort Worth. And again, you just kind of confirming that everything is moving off to the east and northeast, and those trends are continuing. Okay, next slide. So you are an hour into flight, you're 2 hours expected from arrival time. You look at the new observation for your destination, and you have winds out of the northwest at 14 knots and overcast at 2,700. So still MVFR, but ceilings have come up just a little bit. You can see on your flight route as you get into southern Oklahoma, you're going to encounter some light rainfall, but it still looks like those thunderstorms and that deep convection with those sigmets are still well off to the east, and you are going to be able to fly well to the west of them. And then 11 minutes later, you get an alert for a special METAR observation at Fort Worth. And it looks like those ceilings have come up to 3,100 feet. So that's VFR, and it looks like those ceilings are trending in the right direction. And again, you check the latest sigmets and the radar and observations, and everything is kind of trending the way you want to in a favorable direction for you. Next slide. And again, you check those latest PIREPs. Those severe reports are well off to the east. And it looks like there's maybe some light turbulence as you descend into Fort Worth. Some mods off to the west, but those are above your flight level at this point. And the next slide. You are 2/3 of the way in. You're 1 hour away from arrival at Fort Worth. That observation, ceilings continue to come up to 3,500 feet. So you feel good about landing in VFR conditions with winds out of the northwest at 10 knots at Fort Worth. And next slide. And your arrival time, again, VFR conditions continue. You kept aware of the situation, aware of the trends, and we're confident about landing at your destination site there at Fort Worth. One thing to note is that PIREPs are just so invaluable, not only to other pilots, but also to us as forecasters at the Aviation Weather Center. We use them, we look at them, and they confirm whether or not our forecasts are good, or if they need to be changed, they need to be updated, or maybe we're over forecasting turbulence and you send in a no significant weather report, and then we know that perhaps we're over forecasting areas of turbulence or icing. And so those pilot reports are very invaluable, and we really encourage you to send them in as often as possible. Okay, with that, Declan, if you could switch over to our website. Everything that Amanda and I showed you for this case study, we pulled off our graphical forecast for aviation tool. So I just want to quickly go to our website. Under tools, there's the GFA tool. That's where you'll find all of this information. And I know many of you use other apps, ForeFlight, Garmin, SkyVector, like Chelsea had shown. But I just want you to know that if you want to look at the information on our website, this is where you'll find it. And this is a great tool to use as a part of your pre-flight briefing. So the first tab is forecast, and the first one is TAFs. So you can zoom in and out, and those look like observations, but those are actually what the TAF is forecast to do at that particular hour. So you can go forward in time to see what conditions are expected or forecasted by the local forecast office for your particular airport that you're interested in. Going over to the next tab, we have the ceiling and visibility. And this is the forecast tab. So this is the, we're expecting, so this is the flight category that you can look, go through each hour and see how the clouds are moving or what's expected at particular locations you have. And then you can break it out there on the left, like Declan was looking with either just looking at the ceilings or just looking at visibility. So if you have flight, lowered flight categories, you can see what it's mainly due to. Is it ceilings or visibility or both? And then of course go forward and backward in time to see how that see those trends, as we know, is important as well. So the next one is clouds. This is where you can look at the expected cloud tops, the expected cloud bases, and then the coverage. So this is where you have your ceilings, and then they also give you the expected tops of those layers of clouds as well. If you go forward to precipitation and weather, Amanda showed a lot of these, and this just kind of shows you what type of precipitation is expected. And you can again move forward and forward and back through time to your expected flight time. Okay, the next one is thunderstorm activity. Chelsea showed a lot of these. Again, this is pulled right from the local forecast office, so it's collaborative thunderstorm chances, and you can see how thunderstorms move through the day and what is expected for that. Really quickly, the next one is wind. Be careful when you go on max. That's just the max wind throughout the whole depth of the atmosphere. You can decide which layer that you want to look at specifically for if you have a specific flight level that you want to fly at and you want to see what the winds are doing and how they're changing with time. You can do that. The next one is turbulence. again, kind of self-explanatory with this is just a play around with the different levels to see what kind of turbulence you're expecting along your route, and then icing as well. Okay, the next tab over is the observations and warnings. One thing, Declan, if you can go to the map options, I just want to, next to there, yeah. I just want to point out that you can add the SIGMETs, the CWAs, and the G AirMets all overlaid on these maps, so you can see what currently is being warned for out there, where we're expecting icing and what current SIGMETs are out and what current center weather advisories are out. So play around with that and toggle those on and off. The first one we have here is METARs. This is really cool because when you zoom in and you click a METAR, not only will it give you the current observation, the latest observation, but it'll also give you the TAF, so you can see how, you know, how the weather is expected to change over the next 24 to 30 hours. And the next one we have is precipitation and weather. Again, this is like the TAFs or the current observations, whatever kind of, it's plotting the weather symbols there. So whatever is in the observation is on the map there. Going over to ceiling and visibility, these are our visibility. You can click the visibility, you can click the ceiling on the left side. So you have 10 miles visibility, and then here's the ceiling, and then the flight category is the more the one that gives you kind of a better picture with the IFR in red, the IFR in purple, the MVFR in blue, and the VFR in green. And then PIREPs, of course, very, very important, as we discussed before. So current PIREPs that are out there to let you know what's going on. You can see a big cluster of them just along the convection there as expected. Cluster of moderate turbulence. And then finally the radar satellite, which again is so important to keep aware of and to keep looking at. To gather trends and see what the latest developments are. Okay, and then finally, I know we went through this really quickly, so if you go to the info button, you can find out more explanation about all these products in the graphical forecast for aviation tool, and then also there's a short GFA tutorial video set that can help you navigate your way through it. So, okay. With that, I think Stephanie Avey is up next. Thanks, everyone.
Okay, sorry about that. It took me a minute to locate my mute button. Hey everyone, I'm Stephanie Avey. Thanks for hanging in and listening to everyone. It's been great so far. So I am a little bit different than our forecast meteorologist. I am a techniques development meteorologist, and that's kind of just a fancy way to say I work in the back. I'm part of our support branch, and a big part of that is supporting operations, obviously, but also, you know, developing and taking any new ideas or new concepts and working them into the operational framework. So I've been at AWC for about 4 years, and I came from a very different background. I came from a research background, and then I had to learn all about operations and all about aviation, and it's been a ton of fun, and I'm super involved with our test bed. I'm actually our co-lead of our test bed, and so I can't wait to tell you about it. Declan, if you want to change to the next slide. Yeah, so our aviation weather test bed, if you ever get the opportunity to step foot into our building, what you'll notice is our really large operations floor where our forecasters are 24/7, and just across the hall from that we have our test bed. And it's set up very similar to an operational forecast floor with our different computer systems and screens. And essentially what that allows us to do is to bring in various stakeholders and partners and get them in front of these products, get them to evaluate them. And these are products that are right on the cusp of getting into that operational operational framework. So anything that can be used by a plethora of our different users. So we have our forecasters in-house, we have CWSU forecasters like Chelsea, so some products might be helping them. We also have flight dispatchers or decision makers out at the command center. But of course, we also have you all, our pilots. And so that is a very, very vital part of our whole entire research to operations process. And so just the pictures here just kind of, you know, gives you a wide array of how we kind of envision our test bed. It's this whole process of taking new ideas and concepts and researching and developing and bridging them into the place where they can be used for decision making. And so one of the large ways for us to do that is actually to put that out on our website. So Amy did a great job of giving you a tour of the graphical forecast for aviation. That is a product that we have spent a lot of time working on and developing and are continuing to develop and improve on that. And so if you want to jump to the next slide. This is a way that you all can get involved and help us out. So like I said, a really big part of, you know, bringing new products in and getting them into operations is getting feedback from the users. And so we have to make sure that those products are meeting their needs and are intuitive and are usable and all those wonderful things. So we want to get your feedback. We always value that type of feedback. We know that a lot of you are sending messages through the webmail, and that's absolutely fantastic. But we want to get you involved before that product even goes live. So when it's in the experimental framework, and we can get your input before, as we continue to develop on it, we still have that time before it gets into the operational framework. So two of the big products that we're looking at improving and developing on right now, one, obviously the GFA, like Amy showed you, it's fantastic, it's great as is. However, we are continuing to make it even better. I know, it's hard to believe. We're expanding the domain. Right now, we have it expanded over Alaska to serve those pilots up there. And we know it's very different than flying over the CONUS. So it's taking a lot more into account up there. However, we still want to get feedback on the CONUS too. So we are doing a virtual evaluation this summer, and it is going to take place over June and July. And we're hoping to get as much pilot feedback as we can. And this will allow you to get involved no matter how much time you have. You don't have to be, you know, on at a certain time of day or certain many hours. It's really all the time that you can provide. So if you're interested, my email address is down there highlighted in yellow. So please write that down, send me an email. I'll add you to our spreadsheet and we will get in touch with you before, and we'll give you all the information that you're going to need. But essentially, this is going to allow you to check out the experimental product. We're going to ask you some pointed questions, and you're going to be able to give any sort of feedback that you can provide to make that product even better. Another product that we're looking at towards next spring is, I'm not sure if you're familiar with it, but it's our helicopter emergency medical services tool. This is very similar to our GFA product, but it is specifically geared towards helicopter operations or you know, lower altitude flyers. So it has more short-term flight planning and nowcasting of ceiling and visibility and a lot of observation information. So those helicopter pilots can check it out really quickly, make a decision, and go or don't go. So that product, we are actually going to be merging with our GFA product. So they're very similar, but they have some of the same things, and we want to really build towards a more intuitive web experience for our users. So part of that is merging these two products together and creating the GFA low altitude or the GFA LA. And that's expected to be experimental by next spring. So about a year from now, we'll be looking to evaluate that. And fingers crossed, we really hope to do some sort of in-person experiment where we can bring in our different stakeholders and users into that little test bed room I talked about and get feedback there. However, we are still going to need, you know, pilots' feedback from all over the United States and beyond. So tell your friends, get involved yourself. We're going to have that virtual component, so you don't have to come to Kansas City, although it's pretty fun. So please, please, please get involved. We absolutely love getting your feedback, and we really, really do think it's valuable, and we do take it to heart. So if you're interested, once again, that is my email address at the bottom, stephanie.av@noaa.gov. Please reach out to me, and I will get you on the spreadsheet, and you will for sure hear from me. So thank you guys. Thanks for having me.
Okay, well, thank you very much, Stephanie, and also Amy and Amanda for the pre-flight and the en route perspectives on the flight brief, and also for all the wonderful opportunities for folks to get engaged at the wonderful test bed here in Kansas City. So thanks again, folks. We have allocated a little bit of time, of course, as usual, in a presentation of this format and with this many presenters. We're kind of running a little bit behind the 8 ball. However, what we've done is we've accumulated some of your questions during the webinar so far. Bill now will be able to see those questions and basically send them out to the group, at which point the presenters can then answer the questions. But please keep in mind, the wonderful thing here is that regardless of the limited time, we will certainly be able to answer your questions eventually with contact emails and whatnot that we'll show you coming up at the end of the show. Bill?
Thanks, Declan. And thank you, everybody, for attending. My name is Bill Cottrell. I'm a AWC senior meteorologist. I spent 11 years basically in the tropics in Key West, Florida. I was the aviation coordinator there. And I taught meteorology for 10 years to undergrads at the Florida State University. Any questions? I did try to answer Walter's question in the chat session where he was asking what is the time delay on images. Satellite images from GOES are produced depending on what image you're looking at. If it's visible images, they're produced every 5 minutes. But it does take time to get from the satellite to the ground station and then out to the world. Then if you're flying and you're looking on your glass top display or your glass front, you're going to take a few more minutes to get it as well. So there will be some delay depending on how you access the information. Radar images are generally produced every 5 minutes when there is active weather. And that also takes a little bit of time to disseminate through the web and through the world of Wi-Fi. Is there a way to get updated METARS tasks and access to AWC screens in flight? If you have access to the internet in flight, I would assume you could do that. You can, if you're using the iPad, you can bookmark the sections. It just depends on your connection. If you have the satellite connection. Otherwise, I believe that, and somebody else can jump in here and correct me if I'm wrong, but I believe that the in-flight providers do have access for, or they do similar displays on their websites as well. Anybody else? The great thing is in flight is if you have any questions, you can always ask the ATC to verify the information you're looking at. I don't see any more questions popping up, Declan. I know we're running kind of late.
Okay, Bill, thanks a lot for that. And let me get my bearings here. So the next part of the presentation, I got a little driver issue here. Apologies, folks. The next part of the presentation actually is going to involve a very interesting presentation by Paul Suffer, and Paul's going to kind of take over the presentation mode here. And Paul has a very interesting case study dealing with thunderstorms. Paul, of course, with the National Transportation Safety Board. Paul?
Hi, folks, just stand by 1 minute. We're having some technical issues. We'll be right back with you.
Computer audio, is that working?
Yes, we can hear you.
Computer audio working now?
Yeah.
Okay, so I was on my phone and that was not working great. So, okay, great. All right, I apologize for the technical difficulties. I thought phone would work better, but we'll try and give it a shot here with the computer. So, meteorologist Paul Suffren. I've been with the NTSB for 10 years. I've worked about anywhere from 400 to 500 aviation accidents over that time period. Most of my accidents are not high wing or low wing, like this one. Unfortunately, they tend to be more along the lines of this case here in Maryland, or unfortunately something in mountainous terrain, such as this one. And I did want to highlight, I know we're talking about thunderstorm activity and things like that, but in this particular case, things such as just 5 or 10 knots of wind over mountainous terrain can create issues and things like that in particular cases. So there are a lot of weather considerations that we do surrounding accidents, and I know that the team at the Aviation Weather Center has done an amazing job going through about en route forecasts, what's at your departure and destination, when are things predicted, talking about things like the TAF, and it's typically issued every 6 hours, and I'm taking off 5 hours and 30 minutes after a TAF has been issued. It might be a good idea to wait, another 30 minutes for the next round of TAFs to come out. Sunrise and sunset, things like that, dealing with fog and what's in the surrounding area. Don't just check the METAR or the TAF for your departure and destination. Also check things in the surrounding area, other airports, other landing and things like that. So I got a couple examples of cases that involve thunderstorm activity. So this one happened in Florida as an IFR Part 91 flight. The pilot was an airport or airline transport certification pilot. He had over 12,000 hours. He's going from Central Florida, the Sebring area of Florida, all the way up to Clemson, South Carolina. It's kind of northern South Carolina area. He did request and get a flight service briefing at the time before departure. I've highlighted the closest METAR to the accident site here in Central Florida, and you're asking, Paul, it doesn't look anything bad for an IFR qualified pilot, broken at 1200, but a lot of times, like I said, the closest METAR doesn't tell the whole story, and so here highlighted is actually the weather that was more closely encountered by this particular flight. There was some thunderstorm activity, 5 miles. There was a wind shift at the airport and lightning distant in all quadrants. So much more representative of the flight that this encountered here. So for those of you not familiar with that part of the country, there's Florida down in the bottom part of the image. The accident site happened on the way up to the northern portion of Florida, on the way up towards Gainesville and Jacksonville, and as you can see, are headed up to proposed place for the flight was up to Clemson. So for talking at the very beginning of all the presentations, that it was a good, showed some good weather charts from the Aviation Weather Center, or prognosis charts that show where the fronts and low pressure systems are. And that's one of those ingredients that can provide lift if you have moisture. And on this particular day, there was a cold front moving across the southeastern U.S., one moving through the central U.S. As we're speaking right now. But that was the impetus to help thunderstorms form on this April day. Another product that was discussed earlier in the presentation was the Storm Prediction Center Convective Outlook, and talking about not just the green areas, not towards the Teenage Mutant Ninja Turtle green, but more lighter green colors kind of give you where the general thunderstorm forecast, and any thunderstorm is not conducive for general aviation flying. And if you see any of the other colors going up to high risk, that's definitely thunderstorms you want to stay further away from. But in this particular day, there was highlighted a small area of a little bit more severe thunderstorm potential over central Florida area. So the pilot did request lead us text flight briefing the evening before departure, and then received text updates and email updates as the morning went on before this particular pilot departed. They contacted Jacksonville approach as they were going towards this line of weather, and I'll show kind of a little bit more of what that looks like here shortly. But they're at 8,000 feet, and in discussion with air traffic control, they're talking about heavy to extreme precipitation about 60 miles north of the area. And ATC, air traffic controllers, offered vectors to get through an area of least precip. And the pilot was discussing about cloud bases, which, when listening back to the audio tapes in this particular case, it seemed like this pilot was doing, even though it was an IFR flight plan, was trying to do a lot of visual flight rules on this particular flight. But the pilot had a great game plan. If things got worse, they would turn south and head to Ocala, which was south of the weather, and just land there and let the weather, pass over and then depart and go back up to South Carolina. So closer to 9 o'clock, around 8:50, air traffic control provided vectors for the pilot to avoid the area of extreme precip about 30 miles to the north. So here's just a general radar summary over central Florida of what the weather and was there. So you can see a solid line of convective weather, going from one side of the state, and there's not really any holes in this weather. And if we do zoom in further, I've got the flight track of the accident flight on this particular image is pink. And at this time, they're about 30 miles south of the weather. And then there's actually another flight that air traffic control is talking to on frequency, the November 88 Gulf Alpha. And they're being vectored around the worst part of the weather there. You can see to the west of the more red colors. And as we progress with time, so we go about 3 minutes later, the air traffic controller is working that Gulf Alpha, and gets them close as they're making the approach into Gainesville. It's rather bumpy. They're talking about seeing lightning, but they're very fortunate and make a safe landing there, kind of through really the only hole in that area. And as the accident flight there on the pink flight track is making, basically at this particular time is following air traffic control vectors and trying to hit that same hole. So about right around 9 o'clock, 8:57 or so, the pilot was asking if the weather was south of Ocala. And if I go back one image here, and hopefully my mouse, right below where that text block outlined in black is where the Ocala area. So it's actually off to the south and east of the flight plan, or the airplane at this particular time. So the pilot was having a little bit of confusion, it seems like, exactly where the weather was. And the air traffic control comes back with a heavy to extreme as the pilot is heading northward towards the Gainesville area. And the air traffic controller was going to vector to a hole behind that time. Shortly after that, the air traffic control again is trying to vector things a little bit more to the west, 10 more degrees to the left to avoid the worst of it. And then the pilot, we believe, was below the clouds at this time and saw an area about 40 degrees to the right that they thought was a hole visually that he could see, and he was going to try and get through there. So air traffic control again comes back with asking if they want vectors and things like that. And then air traffic control is following up with the pilot about 4 minutes later, asking the pilot how the ride conditions were. And the pilot says he's in clouds, but was seeing some lightning off to the right. So this, unfortunately, is where things did not go as well. So again, you can see the flight track is now the black line as we're headed northward. At about 9:03 is when the air traffic controller was providing information about, turning a little bit 10 more degrees to the left to hit the same hole that the other flight was going into Gainesville on. And this is when the pilot does that 40-degree right turn. 2 minutes later, they're heading up northward to the area, and then unfortunately, right at 9:08 is where there's a loss of control in flight. This particular thunderstorm, in this particular case, I've plotted up the track here. Again, it goes back to in pink, and all the black dots on the screen are all the lightning activity within about 15 minutes of the accident time. There was anywhere from about 500 to 1,000 strikes or so. So not conducive for flying. And this particular thunderstorm actually led to a brief tornado spin up right after the accident. So it was a very vigorous thunderstorm area. So here's a weather satellite animation of the cloud tops, and they were up to about 40,000 feet at the time. So, and here's a weather radar animation of the line of thunderstorm activity as it was progressing from west to east across the state, and as you can see, is definitely building in aerial coverage at the time there as well. So as far as the weather forecasts that were out at the time, as you saw the line of weather on that first image I showed, the thunderstorm or convective activity basically stretched from the west to the east across Florida, and the SIGMETs basically covered that. And you can see all the PIREPs I have plotted on here, green being the light turbulence, and then yellow being moderate, is a bunch of the air carriers overflying a lot of this activity where we're getting quite bumped around. And if I step forward in time, you can see the convective SIGMET definitely highlights the area of where that activity was. So in this case, I know there were some questions about the timeliness of weather radar information, what you're seeing on your tablet, FISB, glass cockpit, anything like that. So we were able to get the FISB information. So that's what's overlaid here. You can see it's definitely a different color scale than the National Weather Service information there, and different what air traffic controller is seeing, but definitely highlights the area of weather that this flight was headed northward for, very convective activity. And then we were also able to get, as I step forward in time, you can see that intense area of precipitation move across the accident site. We were able to pull the XM weather component information with the accident site being right at the middle of the screen, right where you see my canopy, just south of Gainesville area and the intense area. This is the XM weather showing at the exact same time. And if I push forward with time, you can see that band moving from west to east across the my canopy and accident area. But you can see it's quite a bit of delay. If I go back about, if I go to this slide, this was when the intense purple area was actually over the accident site, which is closer to the O in my canopy. So in this particular case, we were seeing anywhere, if you were trying to use this type of information tactically, it's going to be anywhere from 7 to over 10 minutes of difference between what you're seeing on the timestamp in your cockpit. So that could lead to issues. And that's why in the bottom, if you go read all the manuals from XM or ForeFlight or FISB or any of those, they say don't use the weather radar information in your cockpit tactically, use it strategically. Because again, you don't know how long that timestamp delay could be, and it could change as you're going throughout your flight, depending on coverage areas and things. So here's some pictures, unfortunately, of the accident scene. It was an in-flight breakup, and on that case, I believe they found one of the pieces of wreckage of the wing was located about 3 or 4 miles east of the rest of the main wreckage. So it was definitely a very vigorous encounter, unfortunately. So I don't want to highlight that all the issues are just related to general aviation pilots. It definitely goes to the Part 121 world as well. So this is a Delta flight that made a successful and very fortunate and very thankful for a safe landing here in Denver. But definitely you can see the nose and the hail shaft that they flew through were not terribly conducive for each other there. But air traffic control and the pilots did an amazing job after the encounter of getting everyone down safely and not even any injuries after this. So this flight, here's a weather surface chart. It's about June timeframe. This flight is going from all the way looking for those ingredients for thunderstorm activity. Here you've got a frontal boundary, and it's summertime. It's warm and moist. All that moisture coming up from the Gulf presenters we're discussing there. And if we look at the Storm Prediction Center, again, calling for not just regular thunderstorms, but actually potentially organized for severe thunderstorms. So again, something that not only general aviation, but also Part 121 and 135 folks want to avoid there. So here's a composite animation of the flight going from going west-southwestward in southwestern Nebraska, going all the way and hitting kind of the northwest corner of Kansas and the eastern portion of Colorado. And you can clearly see the hole that they're trying to go through here as we step forward with time, and they make that little southerly jog is when they encounter the hail in this case. So what we were able to do on this incident was able to actually capture exactly what the air traffic controller was seeing, doing, and with this particular flight, getting all the audio. And so if any of you have ever had the fortunate chance to visit an air traffic control center, they do not see all the precipitation that you're seeing on your weather radar. They're basically seeing 30 decibel levels and above, which is that blue color on the screen. And as you go towards, again, the Teenage Mutant Ninja Turtle green color, for any of you 80s fans out there, that's getting towards the extreme precipitation. So most likely color-coded either purple or red on what you would see in FISB, ForeFlight, and all those other areas. So the air traffic controller in this case is working the middle rectangular polygon section there, and then I'll highlight the incident aircraft here. So they're coming over from Minneapolis Center Airspace. They're heading southwestward. There's an American flight that's heading northeast bound and a Southwest that's also heading northeast bound. At no point in time do the Delta pilots corroborate that the American and Southwest are heading in the same direction. They're just listening over audio. And they assume and believe that American and Southwest were going in the same direction they were. And unfortunately, the air traffic controller, there was no request by Delta to corroborate said evidence. So about 13 minutes before this incident, the American flight heads through that hole and gets a temperature sensor anomaly because it's very abnormally warm, which means is a clue to the air traffic controller that they're heading through a rain shaft or building updraft, something like that. About 8 minutes before the incident, here the Southwest flight goes through the hole, reports the same temperature anomaly that the American flight did, and also says over frequency, don't send anyone else through there. Unfortunately, the pilots did not corroborate, again, what direction these flights were going. In addition, they received information from dispatch that was delayed or old in this case, they were asking about a reroute, and the dispatcher came back with delayed information and did not really discuss any issues with any kind of closing hole or anything like that. So if we go about 3 minutes before the incident, you can see the Delta flight is about to encounter or try to go through this hole. At this particular point in time is when the Delta pilots come over frequency and said, they'd like to turn and go south around this weather. We believe at this point, they're picking up the radar returns on their weather radar and their nose cone. But again, and this goes back to general aviation pilots, this is where you need to corroborate the evidence that you're seeing with air traffic control. And unfortunately, this was not done in this case. The Delta pilots never provided that, hey, we see this hole. Is it really 20 miles wide, 40 miles wide? Is it getting bigger or smaller? And air traffic control did not offer that information to the pilot there, unfortunately. So they make the turn, and this image here is about 45 seconds post-incident. And you can see they're clipping kind of that northwest edge. And when you listen to the air traffic control audio, you can actually hear when the pilots key over the mics, you can hear the hail hitting the airframe as they're discussing. So very, very thankful that after the encounter, the pilots and air traffic control did a great job getting down safely. And very thankful for that. There were numerous SIGMETs, as highlighted by, this is a weather satellite image with the brightness colors there, the blue colors meaning colder cloud tops or higher clouds. They went anywhere from about 45 to 55,000 feet. And you can see again, numerous SIGMETs highlighting the area of thunderstorm activity that was going on. Not only were these thunderstorms just bad for aviation, there was actually hail and wind damage reported down at the surface there as well. And if we go to what was available to the Delta pilots, so they have a great meteorology department there at Delta, provided other information. And so they have what are termed Delta's SIGMETs, which you can see on the screen here are CN 11, 12, and 13. And CN 11 was sent to the pilots in the cockpit, and that's what they made their decision to, continue on that southwest route. CN 12 and CN 13, which respectively were sent about 30 minutes and about 15 minutes before the incident, were never sent up to the cockpit, unfortunately, in this case. And so it led to the confusion and the unknown knowledge about that hole getting smaller and trying to fit through that gap. So the National Transportation Board had a probable cause for this one, and it's very verbose, and I won't go through all of it, but it just discusses the importance, especially of, as a pilot, making sure that you're discussing what you're seeing with air traffic control. And if you're fortunate enough, if any of you pilots out there work in the 121 or 135 world, making sure that you're getting timely and updated information from your dispatch center if you're fortunate enough to have that there as well. So I'd like to step through briefly of, okay, what in the world does a pilot see, a meteorologist, and air traffic control? If I pick all the same time frame, what exactly is everyone seeing, and the importance of making sure to discuss that. So here on this particular image, this is an accident that happened in West Virginia. On the screen here, you have the flight track there in black, all the black dots. And then on the colors there for the National Weather Service radar is 256 colors. They need all that color enhancement to be able to tell all kinds of things between the size of the droplets and where debris may be, velocity signatures, all different kinds of tools. So they're using this information to highlight many colors. If I go to FSB or things like ForeFlight or XM Weather, you're going to get anywhere from about 3 to 5 colors. So most of the time it's about 5 or so. So you're going from 256 colors down to 5. And then if we're going with air traffic control that's in the center, you're going to get, like I showed in the earlier example, you're going to get 3. If you're talking with tower or TRACON that has weather radar information available to them either in the tower or down in the cab. Sometimes you can get up to about 5 or 6 colors there as well. So it definitely highlights the importance of making sure that you as a pilot are communicating, this is what I'm seeing, I want to use this information strategically. Would it be best to make sure and land at this particular point and let the weather roll over, or do I really have enough area to be able to avoid this by 30 or 40 miles? So have another example from the Part 121 world of if you're looking straight ahead and what the information is showing you, and they have the weather radar tilted at 0 degrees, and then the following image is tilted down about 2 to 3 degrees or so, and you can see off to their 1 to 2 o'clock, you can see highlighting a cell there. If I throw that information from a meteorologist perspective and I throw it into Google Earth and highlight the information there, you can see it tops up to about 36,000 feet. If I'm looking at it from an air traffic control perspective, again, I'm seeing the flight there off on the right side of the screen. They're seeing it in 2 colors. And then again, I go to the 256 colors of what that information was as this flight's going through areas of Missouri. And then I have a brief video. I don't know how well it'll play over the feed. Let me go back just a little bit so you can see that this particular flight as they're flying through is definitely a thunderstorm. They're highlighting by that lightning activity there. So again, highlights the issues. So again, another example I found of another Part 121 carrier highlighting thunderstorm activity off to the 1 to 2 o'clock and what it looks like in real life there. So I know we're running close on time here, so I'll try and I'll skip ahead here, but another similar example. But we do have, from the NTSB side, we do have a lot of safety resources that we've documented and issued. Flight in snow doesn't really apply to this conversation today, but we did talk about pilot reports and the importance of highlighting that information. It goes into the tools like all of the folks at the Aviation Weather Center and testbed are using to make better information. They're going to go back, and you may have landed and not think that PIREP is still valuable, but as researchers are going back to make better tools for you, the pilot, they're going to go back and grab all that information. So even getting a PIREP in the system later is still very, very valuable and very, very important to a lot of folks. And again, highlighting what I discussed in the first example of making sure that as pilots, you're using the information that you see in the cockpit strategically and not tactically, because the timestamp that you see, that's just when that image was made and sent to your cockpit. All the inner workings of when it was compiled back at the National Weather Service radars, and then also sent to whatever provider you're using, whether it's Bisbee, ForeFlight, or XM. They have to use their secret sauce a little bit, so that takes some time, and then it plots up on a timestamp. So you may not be aware of exactly how that is. And so that's the importance of making sure you're having that conversation with air traffic control as you're doing things. So I'm happy to answer any questions as we go forward, and thank you for your time today, and I apologize for the initial delays.
Okay, well, thank you very much, Paul, for that wonderful presentation, a good case study from the National Transportation Safety Board perspective. And actually, that's what we want to reinforce tonight upon conclusion of our webinar. First, we hope you have enjoyed the presentation. We know there were some patches in there, a little bit of bad driving on my part, but I think the information was available, and we're glad you had the opportunity to share part of your evening with us. Appreciate how valuable time is these days. And we want to conclude by reminding you that this is all part of the NOAA Weather Ready Nation initiative. Now, that's a national perspective on how to respond to extreme weather events, because basically the priorities are preventing economic loss, saving lives. And so you may be saying, well, what can you or your organization do in that effort? Well, it's quite simple. Just become a WRN ambassador. And, you know, the thing is about the ambassadors is that on a local level too, can be a very functional, a very valuable asset to have. And that's why we did develop the flyers here in the KC metro area to strengthen the partnerships between our 3 local weather service branches, the CWSU, AWC, and the WFO. So kind of that 3-foot stool to help you in the aviation community locally. And also this is a national perspective. If you want to learn more about the program, weather.gov/WRN, that'll get you started. And there's just an abundance of information available at that site. So now with that being said, we want to just go ahead and thank you once again. Thank you very much for enjoying our presentation, hopefully, and getting lots of information. You can see the contact lists here in order of appearance. Also, any additional questions you have that don't get answered, we certainly will be glad to entertain those. The Facebook, the Twitter, and the internet links are at the bottom. And before we leave, we want to acknowledge a couple of key individuals. Paul, of course, with the NTSB. Thank you, Paul. Jonathan Leffler here at AWC, the Domestic Operations Branch Chief. Ron Moyers, he's our Executive Officer with the NOAA Corps at the Aviation Weather Center. And then the KC Aviators, a local group, Evan Doss and Chris Irish, helping us get this whole ball rolling here for us locally. And Mark Boguski with Live to Fly, a flight instructor, also involved in the educational arena here in the Metro KC area. So again, thank you very much for attending. We will have a post-workshop survey that we will be delivering to your inbox soon. And of course, a reminder that you'll be able to get a recording of this on the NWS AWC YouTube channel once that has been compiled. So again, thank you very much. We appreciate your time, and we hope that some valuable information was gained tonight from you, and we look forward definitely to working with you in the future. Good night, all.